بسم الله الرحمن الرحيم. نستكمل المحاضرة الثالثة من مجموعة محاضرات تصميم مضخات الحريق طبقا لتوصيات NFPA 20. تعتبر هذه المحاضرة الثامنة لطلاب الساعات المعتمدة والمحاضرة التاسعة لطلاب الفرقة الرابعة. ستشمل هذه المحاضرة التعرف بالتفصيل على معظم ملحقات نظام مضخات الحريق والتي تشمل المحابس بأنواعها المختلفة، كما سيتم تناول المضخة الرأسية وطرق توصيلها وتركيبتها في العنابر المختلفة المخصصة للمضخات الرأسية، بالإضافة إلى بعض ملحقات النظام كمشغلات المحركات الكهربائية والمحركات الديزل. OS&Y gate valves with rising stem, which is commonly used to isolate the pump and any portion of the fire pump system using OS&Y gate valve, which means outer screw and yoke gate valve with rising stem to indicate that the valve is open or closed. From a way you can decide and detect if the valve is opened or closed. This type of valves starting from 2 inch, 3 inch, 4 inch, 5 inch until larger diameter up to 20 inch, 24 inch, and it may be flanged or threaded. For small sizes less than 3 inch or 4 inch we can use the threaded, and after larger than 2.5 we can use flanged type, especially where installed in fire pump room we use flanged type. In this slide we can also see the flanged resilient OS&Y gate valve with flanged type as shown here, and the number of bolts is according to DIN standard or ASTM standard for the number of bolts and their size. Also, this figure showing grooved resilient OS&Y to be connected using Victolic connections, and the outer screw is here and the yoke which hold this screw, and when turning this valve the screw going upward for rising, indicating that the valve is open, and when closing the screw going downward to indicate that the valve is closing. This also the cut sheet from one of the vendor of the OS&Y gate valve, indicating here that the valve is UL listed and FM approved. All the dimensions of all the parts of the valve are shown in this tableau. You can get it from different vendors, and the details of the components of construction details are listed also here and will be presented in next slide clearly. This slide showing the power screw, the hand wheel of the valve, the yoke which is acting as a nut of this screw, and the flanges in these two sides, and the gate which isolates the flow with its seat located somewhere here. All the parts of the valve and its material list and specification according to ASTM are listed in this tableau, enlarged from this NEPCO of USA gate valve, which is specialized to produce this type of valves under laboratories listed and FM approved. This slide comparing between the rising stem design and non-rising stem So in firefighting system, we are allowed to use only the rising stem OS&Y gate valve to ensure the valve position if opened or closed when looking it from away. This slide also presents the closed position when the stem is lowered and in the level of the handle. This means that the valve is closed. When the valve is opened, the stem is going upward with certain lengths to indicate that the valve is opened, and you can decide and detect the valve position when looking to it from away. This slide presents a number of OS&Y gate valves of flanged resilient type are installed horizontally with their tamper switch, which is connected to the BMS system and fire alarm control panel to indicate the valve position from opening or closing percentage to the system to monitor the valve and control the valve from away. This slide presents a cut sheet for swing check valve of UL listed and FM approved with the working pressure in PSI range. It may be 200 PSI range of working pressure or 250 PSI or 300. Also shows the flanged ends and its standard. It may be according to ANSI 16.1 class 125 or 150 or 250, or it should be according to EN standard 1092-2 PN10, PN16 and PN25, or BS bridge standard 10 table D or table E. Also the material list of the body cover, clapper arm, hinge, pin and seat of ductile most, the body and cover of ductile iron, and the clapper of carbon steel, and the clapper arm of ductile iron also, and the hinge pin is stainless steel, however the seat is bronze. The specification of each part according to ASTM or AISI is located here. This is with different manufacturer. Molar check valve having according to ISO 9001 for year 2015, that showing that this UL and FM approved, which is made in USA, non-return valve can be used for the application of fire sprinkler system. This slide presents the swing check valve of this slide presents the zone control valve in different configuration with flanges, floor station, as shown, which shall be installed at each floor inside for the building, and with more than 2 floors levels coupled to group each floor network rather other floors network as per NIFPA requirements. Section UL stamp point 1, which will be discussed in the next slides, and its model number ZCB, and this zone control valve should consist of the following items installed vertically. Firstly, where the flow is coming from downward to with tamper switch number is located here, and this check valve may be used of the valve in series with the gate valve to prevent backflow from the network to the riser, or removed. A pressure reducing valve may be added if needed to protect valve from the pressure range of this floor rather than the header, the riser pressure, which may be higher than 8 bar, to protect the sprinkler system as discussed before. During the design of sprinkler system and its maximum pressure allowed which must not exceed 8 bar to prevent high pressure ranges on the sprinkler body. Also, number 4, test and the drain valve should be installed here to connect the drain line to clean out the network or this control zone in maintenance operation. Also, pressure gauges should be affixed here to meter the pressure inside this network portion inside the building. The flow switch paddle should be affixed here to detect the water flow and to be connected. All these control systems of tamper switch and the flow switch should be connected to the PMS system of the building. To monitor the performance of each floor standing alone and comparing between the pressure range inside each floor and the flow of water inside each floor regarding to the main fire pumping system. This slide presents a riser diagram, a typical riser diagram for multi-story building with fire pumping system located somewhere here and another fire pumping system located here and suction tank of fire water tanks, and then the riser diagrams for the fire hose cabinets to be connected on this side of the riser and this side to be connected to the sprinkler systems, and the location of each floor zone control station are located here. So each box of these boxes shown here in each floor entry are consists of the all components should be used as mentioned in the previous slide, with or without pressure reducing valve according to the pressure range of the building to prevent the pressure shall not exceed 8 bar in the sprinkler system in each floor. This slide presents section 8.2, which dedicated for system protection area limitations. The maximum floor area on any one floor to be protected by sprinklers supplied by any one sprinkler system riser or combined system riser consists of sprinkler and fire hose cabinet shall be as follows. For light hazard, the area limitation is 52,000 feet square, which is equivalent to 4,831 meters square. For ordinary hazard, the same area, 52,000 feet square, which is equivalent to 4,831 meter cube. These two area limitations are used for common non-residential buildings such as administration buildings, hotels, hospitals, and malls. For extra hazard, number 3, if we use pipe schedule system for sprinkler system design method, the area limitation will be 25,000 feet square, which corresponds to 2,323 meters square. If we use hydraulically calculated sprinkler system, so the area can be expanded to 4,000 feet square, which corresponds to 3,716 meter square. For storage area with high piled storage and storage coverage by other NFPA standards, the area maximum should be 4,000 feet square, which corresponds to 3,716 meter square. This slide also presents a typical configuration for floor station consists of indicating type floor controlled valve with supervisory switch tamper switch and pressure gauge, and then water flow switch. This is a gate valve with tamper switch and then pressure gauge, and this then water flow switch, and the feed main to be connected from this side to connect the sprinkler system, and this is the riser which supply the water from the pump and discharge the water to the upper floors, and this connection with this T, commercial T, to be used for sectional drain valve or testing valve on bypass with the drain valve with side glass to ensure the water flow and then go to the drain. Also, this slide presents the zone control valve, which is combined unit of single butterfly valve, water flow indicator, pressure gauge, and test and drain valve assembled on fire pipe line. It separates the fire area into small distribution zone for indication and control, as discussed, and the area limitation mentioned in section 8.2, which discussed in the previous slides. This slide presents the details of test and drain valve sizing table. If the riser or main size up to 2 inch, we can use the test and drain valve not less than 3/4 inch or larger. If the for riser or main size starting from 2.5 inch, 3 inch and 3.5 inch, which is rarely used, the test and drain valve should not less than 1 inch and a quarter or larger at least. For 4 inch and larger, the test and drain valve should not less than 2 inch only, not larger than that, to prevent the water flow inside and to keep it the water, and not to test and drain a large amount of water larger than drain size of the building. And this is the shape of the ball valve, UL and FM approved, as shown on its handle here, red handle, to be used for test and drain. If the handle in the same direction with the valve body, so it means that the valve is open. When we rotate this handle to the perpendicular to the body of the valve will be indicating that it is closed. Here in this slide, the pressure reducing valve in different configuration are presented. The two horizontal pressure reducing valve PRVs are shown here. The first is with flanged, UL and FM approved, and the second is with grooved connections to connect to the Victolic type of grooved fittings, and the third type is angle pressure reducing valve with flanges, as shown on the right of this slide. Also, the pressure relief valve are presented here with two configuration, horizontal and angle. Both of them are pilot operated pressure relief valve, which will be connected to the diesel pump discharge line or any portion of expected maximum pressure on the line to protect the sudden increasing of the pressure, even in global pattern horizontal, as shown in the left side photo, or as can be installed vertically, as shown in the vertical angle type shown on the right hand side of this slide. Both of them are pilot operated pressure relief valve. This configuration is of double check detector assembly, DCDA. The double check detector assembly is an outgrowth of the double check valve and is primarily utilized in fire line installations. Double check detector assembly prevent non-health hazard pollutions from entering a portable water supply system when back pressure and or back siphonage conditions occur. Used primarily on fire sprinkler system when monitoring of an unauthorized water use is required. So that connection of double check detector assembly isolate between the firefighting system and the potable water supply system for different back pressure and back siphonage conditions which may be happen in fluctuation of the pressure, especially for the potable water supply when the fire fighting system is connecting directly to the city main or to the internal potable water supply network for certain projects. Another details showing also the double check detector assembly. Its purpose is to protect the potable water supply line from possible contamination or pollution from the fire system, back pressure from fire line booster pumps, stagnant backwater that sits in fire lines over extended periods of time. The addition of the non-potable water through outside fire district connection, fire department connection, and the detection of any water use in the fire line due to fire line leakage or deliberate water theft. It consists of two spring-loaded check valves, a bypass assembly with water meter and double check valve, and two tightly closing OS&Y gate valve for isolating this set of double check detector assembly which protect the firefighting system against the different operating condition with which have connected to the other potable water system or booster pumps or stagnant back pressure or back water or safety of waters. Another configuration showing the shut-off valve at either end and at each end. It can be connected from one side or connected from two sides to prevent the backflow from two sides or one side in different operation condition as shown in these two comparative drawings. Then we will switch to the pump room of horizontal split case with diesel engine and its ventilation, typical ventilation system for heat exchange which should be provided to cool the diesel engine driven and to ensure an air change not less than 12 air change per hour up to 30 air change per hour to remove the heat released by radiation from the diesel engine inside the pump room, and that will affect all the other system components inside the pump room during the pumping system operation and in condition of working of the diesel engine in its full capacity. So an air supply should be provided with this damper must be opened during the operation of the diesel engine, internal combustion engine, to remove the heat dissipation and to be discharged outside the fire pump room to prevent excess temperature inside this fire pump room which may cause damage for other controlling instrumentation and controller and electrical motor inside this fire pump room and also the operators. Different configuration with right configuration of typical ventilation system for radiator cooled diesel driven pump, and this rung it's recommended to use a turning vane bend to prevent turbulence at flow restrictions, and it's not allowed to use this sharp square elbow on the radiator which will make a lot of noise here due to flow separation, and in case of non-using non-turning vane in this discharge elbow for radiator. Also this configuration showing how we can connect the radiator with this flexible section to discharge air, remove the air outside of the fire pump room, which is directly coupled with this diesel engine as shown on this diagram. So also cold weather restriction duct should be provided here in cold areas should be considered, and the air supply ventilation should be considered according to the wind direction. We can locate these louvers for air intake and these louvers with dampers, motorized dampers on both sides for air intake and air discharge louvers with motorized damper, which must be interlocked with the operation of the diesel engine to be open just at once when the diesel engine is running on. Chapter 4 will discuss the vertical shaft turbine type pumps. The sustainability, where the water supply is located below the discharge flange center line and the water supply pressure is insufficient for getting the water from the fire pump, a vertical shaft turbine pump shall be used. Characteristics: pumps shall furnish not less than 150% of rated capacity of total head at not less than 65% of the total rated head. The same conditions which indicated also for horizontal pump in chapter 3 as discussed before. In previous lecture, the total shut-off head shall not exceed also 140% of the total rated head on vertical turbine pumps. Water sources: the water supply shall be adequate and dependable and acceptable for the authority having jurisdiction. The acceptance of the well as a water supply source shall be dependent upon satisfactory development of water well establishment, satisfactory aquifer characteristic. Pump submergence, well installation and wet pit installations. For well installations, proper submergence of the pump bowels shall be provided for reliable operation of the fire pump unit. Submergence of the second impeller from the bottom of the pump bowl assembly shall not be less than 10 feet, which corresponds to 3 meters, below the pumping water level at 150% of rated capacity. The submergence shall be increased by 1 feet, which corresponds to 0.3 meter for each 1000 feet, 305 meter of elevation above sea level. For wet pit installation, to provide submergence for priming, the elevation of the second impeller from the bottom of the pump bowl assembly shall be such that it's below the lowest pumping water level in the open body of water supplying the pit. For pumps with rated capacities of 2000 GPM, which corresponds to 7570 liters per minute or greater, additional submergence is required to prevent the formation of vortices and to provide the required net positive suction head and PSH in order to prevent excessive cavitation. The required submergence shall be obtained from the pump manufacturer. So in this slide we have discussed most recommendation for pump submergence and general characteristics to be taken into consideration during installation for vertical shaft turbine type pumps, and the water supply and the sources restriction should be used as acceptance and dependability and satisfaction, and according to the authority having jurisdiction for the installation of both well installation and wet pit installation. And all these uh, terminologies will be discussed in the next slides. The pump line shafting shall be sized so critical speed shall be 25% above the below the operating speed of the pump. Operating speed shall include all speeds for shutoff to the 150% point of the pump, which vary on engine drives. Bowl assembly. The pump bowl shall be of closed grained cast iron, bronze, or other suitable material in accordance with the chemical analysis of the water and experience in the area. If used well water or seawater, so the material of each pump component, especially for pump bowl, should be considered according to the chemical composition and chemical analysis of the water to be delivered. Impellers shall be on the enclosed type and shall be of bronze or other suitable material in accordance with the chemical analysis of the water and experience in this area. Suction strainers. A cast or heavy fabricated corrosion resistance materials cone or basket type strainer shall be attached to the suction manifold of the pump. The suction strainer shall have a free area of at least 4 times the area of the suction connections, and the openings shall be sized to restrict the passage of half-inch spheres, which may be contained in the water. So we have to take into consideration all the solid particles which may be suspended in the water during suction from wells or sea water or rivers or any other water sources, which may be used when the water level is lower than the network level in the location of installation of this fire pumping system using vertical turbine pump. For installation in a wet pit, the suction strainer shall be required in addition to the intake screen. Also, the main components of the pump, vertical pump, is located here. This is a basket strainer, maybe in some cases fish strainer when using in seawater or river. We can use fish strainer here also in replacing this basket strainer. Then the enclosed impeller stages are located here, and the bowl assembly containing the impeller inside it is located here, and its material, as discussed, should be considered. The chemical analysis of the water to be installed in it, and the vertical shaft, very long shaft, is located here with coupling and vertical motor installed here, and then the discharge elbow and discharge T to connect to the relief T valve or air vacuum. Air and vacuum should be also connected here to prevent air from the passage of the water, and then we can install the discharge line check valve to prevent backflow and to keep the pump in priming condition all of the time to deliver the water from the water level located somewhere here to cover this impeller located inside this column assembly as shown on this diagram. Presents vertical turbine pumps. This slide also presents the installation of vertical turbine type pump in a well with the same components discussed before in the previous slide, such as basket strainers, suction nozzle, maybe installed here, and this is the minimum submergence which mentioned previously. 10 feet, it should not less than 10 feet, the submergence of the pump in the well, and the pump bowl assembly with many stages, and the drain down, and this is the static water level before pumping. Here, however, we will pump the water to increase the static head of it and the total head of it to overcome all the friction will be faced in this network as per the fire network design. The motor is located here, and the pressure relief valve with air valves, non return or check valve, discharge line, and discharge gate valve is located here, and this is the line for testing which have we also discussed for horizontal with drain valve or ball drip valve located here. This pump should be clear that it is driven with electrical motor vertically installed and closed coupled to its shaft, and the discharge pressure gauge is located here. However, this slide presents a vertical shaft turbine installation in wet pit instead of well. The installation also with electrical motor vertically. However, we keep the water from the source to be entered inside this wet pit, where we installed the body of the pump with a strainer and power assembly containing the impellers and the shaft, vertical shaft, and then we will install the pump in this pump house above, which is superstructured above the wet pit located here in the same level with the water, even from river or open source of water, lake, pond, maybe located for water here from lowest standing water level up to high water level, maybe fluctuated the water level. So the submergence should be prevented from the lowest standing water level as discussed early in these slides. Then the valving system to connect the fire underground fire water network to be served from this water supply using this vertical shaft turbine pump inside wet pit and superstructure pump house. This slide comparing between the total head and the vertical distance to the datum of the vertical pump from the pumping water level to the center line of the pump, which is our datum, and the total discharge head in the discharge line according to the friction until reach the final discharge tank after suction from this level of static water level, and pumping water level will be located here, and this is submergence drawdown of to ensure that the pump is covered with this drawdown below the static water level. So the pump will pump the flow from this level until reach this level, which is higher than the final tank water level with the discharge velocity head in the discharge line. So we can split or divide this total head into two main parts, mainly starting from vertical distance from dating, which equivalent to the H total head in the suction side, and plus the total discharge head, which named here HD, which contains HV plus H friction on discharge line. So also this configuration showing the sump water level and the strainer here, and the starting of assembly Powell assembly and the impeller is located here, and this is the sump floor here, and this is the discharge, and this is the discharge pressure gauge, and the motor is installed vertically here with air release valve to prevent the air from the water passage as discussed before. This slide presents how to connect a diesel engine with hooks joint to the vertical pump shaft with multi-stage pump, and the diesel engine its shaft should be horizontally as typical internal combustion engine. So we have to connect the pump shaft here inside this casing with hooks joint, which prevent perpendicular movement of two rotational shafts from these horizontal shafts of diesel engine driven, and the vertical pump shaft, which is located here vertically as described before, based on this type of vertical shaft turbine pump theory of operation. Different orientation of the fuel pump, the fuel tank, and the fuel connection to the diesel engine, which drive the pump in 3D. Also, this slide showing different sectional view and plan views and side views for installation of vertical shaft turbine type pump in a wet pit with diesel engine driven, and the coupling between the horizontal shaft of the diesel engine and the vertical shaft of the pump. Then we will switch to the fire pump controllers as shown here. Each pump should complete with its controller. Electrical fire pump controller should be installed to control the operation of electrical motor of electrical driven fire pump. Also, a diesel engine driven fire pump controller should be installed to control the diesel engine which drive the fire diesel engine driven pump. So in this slide we will compare between different types of electrical fire pump controllers when its doorway is closed, with the frontal control panel is closed, showing the control monitor, and the monitor here to monitor the performance, electrical and hydraulic performance of the pump can be monitored from this window, and the controller may be of star delta controller from inside with two contactors here, one for star connection and one for delta connection, and must be the third to switch between the star and delta after certain starting time, or it may be of direct online controller type as can be seen in this type. However, for diesel engine there is no contactor but different control instrumentation such as relays and monitoring instrumentation for the diesel engine performance monitoring, and for the fuel tank, and also for the fire pump with diesel engine driven to control and monitor its performance from this window on this screen located in the frontal board and on this fire. In this slide we will discuss the HQ curve for horizontal split case fire pump and the main characteristics which should be provided by the pump manufacturer to accept this pump as a fire pump as per NFPA 20. So if we have the rated capacity in this point 100%, the curve must be extended to 150 as mentioned before, and the pressure at this point should not less than 65% from the head at this operating point. So the curve may be flat, totally flat like this curve, or steepest shape permissible, but the shutoff head should not exceed 140% of the head of the rated capacity or the operating point at the design point as mentioned before. So on this graph we can find the meanings of the pump characteristic curves which have been discussed in both chapters, starting of chapter 3 and chapter 4 for the fire pump, even horizontal or vertical, but at maximum flow at 150% of the flow, the pressure should not less than 65% of the head of the total rated head at the operating point, and also at shutoff point at which the valves is closing in front of the pump. The shutoff head at no flow condition should not exceed 140% of the rated head capacity as mentioned in the general requirements of centrifugal pump and vertical type turbine pump, which have discussed in chapter 4 in this lecture and in the previous lecture for horizontal pump. The pump characteristic curves are also shown here, but in this graph in GPM. So if we have a pump with 1500 GPM and the head will be 80 psi, which is equivalent to 5.4 bar, so the pump curve at 1.25, which is corresponds to 2250, the head at this point should not less than 65% of this total head of 80 psi. So if the pump curve fulfill this condition and also the shutoff head does not exceed 140, then the operating point at or pump rating head at shutoff at zero condition at no flow, so that is accepted fire pump characteristic curve after tested, and all pump manufacturers are taking into consideration the pump characteristic curve requirements and recommendations by NFPA 20 during their designs and their marketing for UL and FM fire pumps, even for horizontal centrifugal pumps in suction or split case horizontal pumps, or even for vertical turbine type pumps. So also for HQ curves, after we have testing the characteristic curve between the total head and the GPM and ensuring that it covered all the requirements of NFPA at 150% of the rated flow, the head not less than 65% of the rated capacity, and the shutoff head, we also should consider the efficiency and the brake horsepower of the driver, even electrical motor or diesel engine driven. It should cover the flow at 150. So if we have a pump with 500 GPM, for example, in this case, so the flow rate at 150% will be 750, located somewhere here before the 800 by 50 GPM. So this point must be reached on the HQ curve. So the brake horsepower necessary will be read on this curve about 50 horsepower. So when we select or if we need the curve to be extended to here, so we will take this point of brake horsepower and then select the motor with service factor about 150 or 120% over. If it's 50, we can take the motor 60 horsepower. If it's about 45 or 55, we will take it about 75 brake horsepower. So we will check also the efficiency. However, the fire pump is not operating all of the time, such as HVAC system or potable water system, so the efficiency, it should be considered that at the operating point or at maximum flow point of 150 should not less than about 60% or 70% or 80%. It's recommended, but it's not a major problem to select a high efficiency because that fire pump it's not working until for certain duration during fire case. Also, we in this graph we can consider that if we have a high level tank, we have to take into consideration the friction factor and will not need to estimate the static difference, such we have a larger static suction head on this pump suction head, as will be also shown in next slides, comparing between the static suction head and static suction lift and their effect on the centrifugal pump. This P and I D have also discussed before to finally conclude how to connect the main fire pumps with their supply tanks and in parallel to each other, with each isolating OS&Y gate valve on suction lines and on discharge lines and non-return valves, and also for testing lines which may be connected to the hose valves manifold or bypass with metering device with two isolating OS&Y gate valves, or to be returned to the tank for any recirculation purposes, and also to be connected finally to the system to be served and protected with these fire pumps to be supplied by the source of the water, even the fire water tank underground or above ground or high elevated tank, or from city main. Also the jockey pump should be connected in parallel to keep the pressure of this pumping set as discussed before. So this diagram is named as a diagram of preferred arrangement for measuring fire pump water flow with meter for multiple pumps and water supplies, water discharge to drain or to pump water source again. This slide presents a typical water mist system pump and its piping and fittings during connection together to ensure the performance of water mist system. The water supply should be provided from this side and OS&Y on suction isolation gate valve. A strainer should be installed, suction strainer of Y pattern, to ensure the purity of the water supplied from the suction tank, and 3.5-inch compound suction gauge should at least, as discussed before, should be installed also in suction side and discharge side, and the pump suction port to be located here and pressure relief valve to be connected here with acceptable method to return relief valve flow with side glass. Maximum possible distance should be kept here between these two location points, between the suction port and the return points must be kept this maximum to avoid water circulation with high flow larger than pump capacity and pump enclosure, and pump discharge port then to be connected to the main discharge line with check valve and OS&Y. Orifice plate can be tested here for test flow loop and also should be returned back to the main supply line, and then this water to be supplied to the water mist system. So it should be clear that most of these configuration are typically similar to the main fire pump, but with taking into consideration some ports, especially for this strainer, which must be located here to ensure the purity, especially for using a very fine sprays which will use a high atomized water in water misting system. Also here we can take a note that there are here a pump discharge should be a pipe 10 pipe diameter should be kept between the strainer and the pump suction to ensure a straight length entrance length enough about x L over D equal 10, not less than the length should be equal about not less than 10 the diameter of the pipe to ensure the entrance length sufficient for the stable pump operation and avoid water separation in suction site and vorticities. These are typical components with motor mist system components, starting from the water tank here, and then the pump, the main pump, and the compressor which compress the system to ensure the water mist, and the system is splitting into connections, one of dry system if using in a cold space or refrigerated space. We will use dry piping system of this mist system branch, and for typical application with frost protected rooms we can use wet pipe system with frost protected room, but if it subjected to frost hazard we will use dry pipe as shown on this part of the system. So this is the controlling fire controller, pump fire controller, and it should be connected to the fire alarm control panel with audible and viewable monitoring, and alarm system should be connected here, which may be connected to the fire department to contact them in fire case. And all these components of to control and to allow the water flow and the pressure and amount to be controlled during operation of this sophisticated, and should be designed by the manufacturer of this water mist system, and its vendor should review and issue and review the design, and maybe reviewed based on the engineered of the project and according to the requirements of the owner of the project, according to the need and of the application of its operation. This table is showing the speed of induction motors even for 230 and 460 volts under using electrical network of 60 Hz or 50 Hz. For example, in fire pumps we use one pair of poles, the number of poles is 2, one pair, which means one pair. In Egypt, for example, we use 50 Hz, so the speed, synchronous speed is 3000, but the full load speed may reach 2900 or 950 due to slapping of the rotor. In 60 Hz networks we use also one pair of pole, which means the number of poles is equal to 1 pair, so the speed will be 3600, which at full load and voice slipping, which may reach 3550 or 3460 at full load speed due to locked rotor ampere. So this helpful tableau can help the mechanical engineer to detect the speed of different types of induction motors as per their number of pair of pole and frequency of the network to be used in different countries. At the end of this lecture, we will compare here between static suction head and static suction lift for different pump installation, and we will also review the pump installation information. The static head is the hydraulic pressure at the point in a fluid when the liquid is at rest. However, the friction head is the loss in the pressure or energy due to frictional losses in the flow. The discharge head, the outlet pressure of the pump in operation. The total head is the total pressure difference between the inlet and the outlet of the pump in operation. And finally, the suction head is the inlet pressure of the pump when above atmospheric pressure, and the suction lift, the inlet pressure of the pump when below atmospheric level, as shown on the figure here. This pump is operated with a static suction head, such its suction is provided with high water level than its center line, which is the datum, for both free water surface inside the suction tank and inside the discharge tank. This is static discharge head and this is static suction head. The difference between them is the total static head, which is mentioned here as a total static head. However, in this figure, the pump need to be primed to ensure that the suction line is complete with water and containing water, and there is no separation in water column in suction side. And this configuration, when the free water surface of the suction tank is below the center line, it means suction lift. The static suction lift instead of static suction head. So the total static head in this case is equal static suction lift plus static discharge head. However, here the total static head is equal the static discharge head minus the static suction head. This also typical pump installation showing the different amount of head of gross pumping head and discharge resistance, which is a friction head, and delivery velocity head. And friction can be divided, the discharge resistance can be divided into two parts. The first part is delivery velocity head and delivery friction head. Then the static head can be divided to the net discharge head and net suction head. This is static suction head. Static head total consists of net discharge head and net suction head. The discharge resistance consists of delivery velocity head and delivery friction head. However, also suction resistance on suction can be splitted or can be consists of two parts: suction friction head and suction velocity head. And this is the water level in the suction side, and this is the water level in the discharge side, and the hydraulic power of the pump is equal gamma QH. This is the fluid power of the pump can be considered, and this is the pump center line, which is the datum to be meter the suction head in suction and suction head in the suction side and the suction head and the static head in the discharge line, and the static head in suction side. So we can now solve the problem to estimate the pump head according to the previously studied modified Bernoulli equation and according to the pump data we have provided during this set of lectures about fire pump according to NFPA 20. Thanks for watching, and now you can go to design a complete system. It consists of fire sprinkler systems and fire hose cabinet system, which have been supplied with typical arrangement of horizontal or vertical fire pumping units with diesel engine or electrical driven motors in assistance with jockey pump and all system components such as OS&Y gate valves, non-return valves, pressure relief valves, pressure reducing valves, zone control valves, and all system components such as piping. Using all the data have been studied during this set of lectures and also inside the previously lecture about the water sprinkler system. Thanks for watching, and seeing you in next lecture about advanced firefighting system and smoke management system for firefighting system design. Thanks.